The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome to Young Engineers of Today, and welcome to Amazing Mechatronics. Actually, mainly Amazing Mechatronics. We're going to be spending the next 3 weeks working through the different presentations that we have here for Scratch to get ourselves familiar with it and programming. Joined by Mr. Dubik. My name is Mr. DeToy. You can call me Thomas or Mr. DeToy, either one. And we'll get you through the next few weeks with make it about as interesting as we possibly can.
Yes. Tom, let me just jump in there. This is Tom Dubik, and we're calling it Amazing Mechatronics. The event will be Progamers. So if you're thinking, hey, I'm signed up for Progamers event, what are we talking about? This is to get you ready. Tom, if you don't mind, I'll take just a quick minute and explain what the event will be this year, and we'll get everybody set.
All right, go ahead.
All right. Thank you, sir. I appreciate it. Okay. Folks, let's go here, Scratch. Let me watch the screen here. Oh, you've got control. So if you can hit next screen down to Scratch.
Oh, sure.
Go ahead and pop. Great. So Tom's got it. All right, excellent, excellent, excellent. Okay, folks, some of you right over on the right hand, before we go any farther, there's a dashboard, and you can raise your hand. If you see Scratch 2.0, raise your hand so we know you're there. Excellent. Great. Tom is recording this. I'm going to try to record it as well, or hopefully he's recording it right now.
Mm-hmm.
So that way we will post it. So if someone doesn't make it, we're recording it. All right. Now, all right. So here's I'm at a school right now. We're all working, getting ready for our events, and we're actually, pizza just got delivered. Timing's extraordinary. I think it makes me smile. But in any case, the event this year that you're going to be in is a trial event, and it's called Progamers. And what you're going to do in this trial event is there'll be a game that's already made. You will go back and then make parts of the game. So the more of the game you get finished, the higher your score you will be. This is a trial event. So parents that are listening, I appreciate your patience. We will learn a lot about as this event goes on through the year. Well, as we go through the events, but because it's a trial event, there will probably be medals go out, but it won't change your team's ranking. So don't feel like, oh my gosh, that oh no, we didn't do great in this event. That's okay. And you're in good hands with Mr. DeToy. He's a very good instructor and has been teaching Scratch and programming and embedded programming for quite some time with me. So I'm the writer who's created the event. And so if you've got a problem with the event or you want to fuss at someone, fuss at me, don't fuss at Tom, don't fuss at Kim Gervaisi. We're helping out. So hopefully you won't have any reason to fuss at us. But for the next 3 weeks, we'll have this. Now, we may get done, too. We may end up where there's not a reason for us to meet the final 1 or 2 times. But again, we'll have it recorded. Because of the nature of the event, we don't have a lot of example questions because we're limited in what we can do in regards to that. We want to share. Does anybody have a question? If you raise your hand, please. Okay, I don't see anybody. There's hands raised. I'm gonna put everybody's hands down. Or Tom, can you put everybody's hands down? Then we'll see if. Oh yeah, all the hands are down. If anybody's got a question now, raise your hand. Okay, we got a couple. All right, let me go ahead. I think to unmute. Yes, sir. What's your question? Hello. And Josh. I'm not pronouncing this properly. I apologize. Anjali, Anjali. How do I pronounce that?
It's down on the question box. When will the event take place?
It's pronounced.
Oh, okay, great. The events will take place. If you're in Raleigh, they'll take place beginning of February. In Charlotte, it's March. If you go on the Science Olympiad website, they'll have it there.
Mr. Dubik?
Yes.
Right now, it's not Anjali, it's her son speaking
Right.
for her.
Okay. Great. All right, what's your question, buddy?
Yeah, it was when will the event take place?
Yeah, you'll have to look on the Science Olympiad map. The one in Raleigh, I believe, is the first week in February. The one in Charlotte is in March. And then
Okay,
we have,
cool.
being a trial event, we roll it out at just a few places to make sure we're good to go.
Okay.
All right, then. I'm going to go ahead and hand this off to Tom, his capable hands, and we wish you the best. And I'm going to go work with my teams on other events. Okay? Thank you.
All right, thank you, Mr. Dubik. Okay, so yeah, from here on out, you're stuck with me. Well, sort of. We're gonna work through all of these and get ourselves pretty familiar with Scratch, and by extension, sort of the I'm looking for a word that's escaping me right now. I guess the sort of the conventions of coding, which sounds a lot scarier than it actually is. What I'm gonna have you guys do by the end of these 3 weeks, hopefully, is think like coders, which is a little bit different than you'd expect it to. Computers think a little bit differently than humans do. In fact, computers think a lot differently than humans do. So a big part of being a programmer and a big part of being comfortable with programming is learning to think how a computer thinks. Thankfully, it's not too hard because there's this phrase that I always use, and you guys will be pretty familiar with it by the end of this, but it's that computers are dumb. And you guys will get pretty familiar with that in its own right. Where's the event in Raleigh? That is an excellent question. Let me see if I can't look that up for you right now. Just pulling up the information. Okay, so there is an event on March 24th at Middle Creek High School, but I'm sure since there are trial events, as we get closer to the event, you'll get more information about where that trial event may be if it's in a different location. Just keep your eyes peeled on the NCSO website, and it should contain the information there that you're looking for. Yes, but back to the original phrase, computers are dumb. That sounds a little insulting to computers, and in a sense it kind of is, but there's a reason why I say that, and you will begin to understand that as we get further along in this. And that is, a big part of it is, we as people, we can sort of draw connections and things like that. We can say, oh, hey, for instance, the stove is hot, and when you put cold food on it, the food gets hot. So maybe there's the stove is transferring some of its heat to the food. We can create connections like that. Oh, you know, the moon. Every time the moon gets closer, the tide rolls in. So the moon has some effect on the tides or something like that. Computers can't do that. They can only do the things we tell it to. So a lot of times when we're sitting there and going, oh man, why isn't this working, or what's going on, what's going wrong, it's because either we forgot a step in the process of explaining how a computer should do something. We made a connection in our head that the computer didn't, or the way that we set up our connections, the computer moved happily along this path of connections, and it went in a different place than we anticipated because there was another part that we didn't take into account. So that's what I mean when we say that computers are dumb. Computers only do as much as we tell them to and no more. So part of the way of thinking like a programmer is getting familiar with that concept and thinking of how to break down everything that you want to do into smaller and smaller steps until it gets to a point where you can explain every step to a computer and have it make sense in a way that it needs it to make sense. So that's what we're looking to do. So like Mr. Dubik mentioned, we're going to be using Scratch, and there's actually a nice website for Scratch. I'm sure you guys have probably messed around with Scratch a little bit. If you haven't, that's fine. You will be very familiar with Scratch by the end of this. If you have, fantastic. You already know at least a little bit of what it's about. But it is a free, very visually based programming language. Great if you want to learn programming. And it is available on MIT's website. So a big part of what we will focus on today is sort of getting set up with Scratch, getting used to Scratch, doing all of the sort of initial creation of an account and things like that, and then just sort of a gentle introduction to programming and the different terms and things like that. So let's go ahead and do that. I'm going to go to Scratch's website. Scratch.mit.edu. I don't know why. Let's just change that back to that. There we go. So you should be taken to a page like this, and this is Scratch's website. If you've been here before, you know about it. If you haven't, a lot of times you've got other projects that you can look at. You can see what people have made with Scratch, and it's pretty interesting to see exactly how varied the projects can be. You've got popular ones, including popular makers and things like that. You got a little tiny tutorial video on Scratch. Oops, and I liked it. You can check out examples, see different code bases and stuff like that. Join Scratch and give it a try. So what we're going to do is we're going to join Scratch. Now, this process might take a few minutes because I believe all of you are going to need parental permission in order to create a Scratch account. So what you want to do is you want to choose a Scratch username. That one already exists because I already have a Scratch account. But you want to pick a Scratch username and a password. Let's just throw a 1 at the end so that we can walk through the process together. I know I'm horrible, stealing all the good usernames. But yeah, choose and confirm a password. When you hit next, it'll ask you for your birth month and year. I'm going to set this to, I believe the cutoff is 13. So let's try December of 2004. You can select one of the 3 genders here, and then pick a country. Hit next. Yeah, so 13 is okay. Let's try 12. Yeah, that would make 12. I had to do it, but yep. So 12 and below, you'll need a parent or guardian's email address, and then Scratch will send them an email in order to confirm this account. You'll be able to continue if you don't, if I remember correctly. I'm trying to think of, because there are a couple different programs that ask different things. But with Scratch, at least, you'll be able to use Scratch. You just won't be able to save anything that you make, at the very least. Maybe thinking of Tinkercad. Anyway, regardless, I would recommend that you coordinate with your parents and get that account all set up. What I'm going to do is I'm going to give everybody a few minutes to get an account set up. I'm just going to sort of sit here quietly and sign in. If you've already got an account, or if you get an account created, go ahead and raise your hand so that I know who's got what. And once we got most of the hands raised, we'll continue along and move on to the next step, because I want to make sure that everybody's on the same page. So I'm going to do this a lot. There will be a lot of times where I just sort of leave everybody to their own devices for a few minutes. Do not fret, though. If you have any questions, you can always throw them in the question box while we're doing this, and I'll keep an eye on the question box. And as always, just raise your hand when you're done. All right, we got a few hands up already. Perfect. Looks like we got a few Scratch veterans, or people who are really fast at making accounts. right, we're just waiting on a few more hands, and then we'll continue. In the meantime, while that's happening, I'm going to run and grab some water real quick, so I'll be right back. Hey, Ashita, when you say, do you have to follow what I am doing, do you mean like if I start making a program, you should follow along with the instructions? Uh, because I'd recommend that just because if you're not familiar with it, it'll help you get familiar with it. If I'm doing something pretty basic, like setting up a variable or something like that, yeah, you might already know how to do that. But it might be leading into something that's a little bit more complex that builds on that. So I would recommend, yeah, following along, definitely. All right, looks like we've got just about, we don't have quite everybody's hand up, but just about everybody. So what I'm going to do is I'm going to get us going forwards a little bit here. There's going to be probably a fair amount of explanation anyway, so fear not if you're still setting up an account. I don't think you're really going to miss much at this point. And if if at any point you guys are working on something and I cover something and it doesn't really make sense, or you want me to go over it again, or maybe you were focusing on something that you hadn't quite finished yet and I talk about something else and you miss it, please, just feel free to throw that in the question box. Hey, what was that about so-and-so? I can walk through it again just to make sure that we're all doing the same thing. I want to make sure I don't go too fast or too slow. But too slow is a little bit more preferable to too fast, because then at least we've got everybody, understanding everything. All right, so we log in. You can check out profile here. So yeah, if I click on my little name here, I can see profile and then all the stuff that I've been working on. I've been working on nothing. I have been working on stuff throughout the years, but I always sort of clean it out. As you can see, 3 years ago, I always sort of clean it out at the end of the year, just so A, I don't spoil anything for anybody else, just so you don't know what's coming, and B, just because otherwise I do this for a number of different classes over the years, and the thing would just be cluttered with all kinds of different projects. So what I'm going to do is, now that I'm sitting on the home page, you can always get to the home page just by clicking the little scratch logo. I'm going to click on Create here, and I'm going to enable Adobe Flash Player. I'm working on a work computer, so it doesn't have all of the things that I'd like. So here we are. This is automatically titled, well, for lack of a better term, since it's called Untitled. Yours will be called probably just Untitled. Mine is called Untitled 8, because apparently I've created at least 7 more Untitled projects before that. You might think it's kind of silly that I said at least 7, but there's probably one that's just called Untitled, and then they went Untitled 1. But maybe they went Untitled 2 directly afterwards, who knows. Anyway, that's not really here nor there. I'm just going to keep it as Untitled. So let's check out the project editor and see all the different stuff that's on here. Go ahead and throw everybody's hands back down. So we've got project area. Well, this is the project page. We've got the blocks tab. We've got the scripts area. We've got the stage. We've got the sprites and backdrop, the costumes tab, and the sounds tab. And we'll walk through all of these individually so that you guys know what you're looking at. Yeah, so we got that. So the blocks palette here, this little scripts tab with all these different blocks and stuff like that. These are all blocks because you can drag and drop them and they click together like Lego. So that's why they're referred to as blocks. This blocks tab, or this blocks editor in the scripts tab here, as you can see, you've got a whole bunch of different blocks, and these are basically all of the different things that you can do when you're working
Oh, gotcha.
Scratch. And Scratch has a very, very sort of user-friendly way of making programs. All you do is you just drag and drop things and click them together. Notice how I got a little white line underneath that say hello for 2 seconds, and then when I release, it just snaps to it. This is the basis of how Scratch works. Everything is just drag and drop. So all of the different things that you can drag and drop are listed here in the different categories. So we've got motion, and that deals with moving the cat around. Looks deals with changing the look of the cat or whatever sprite you have in there. Sound is different sounds that it might make. Pen is stuff that you can draw. Data is sort of different numbers and words and stuff like that that the program can hold. Events is determining when the program does certain things. Control is making the program do different things based on the state of the program. So like, let's say there was a variable that had a certain value in it, make the program do something different if it had 10 versus if it didn't have 10, stuff like that. Sensing is listening to keyboard and mouse inputs. Operators, math, scary math. It's not really that scary. And more blocks is stuff that you can create yourself for, just use. We're going to sort of familiarize ourselves with all of these, not all of them, but with enough of these different blocks so that you can feel confident to sort of mess around and see what the other blocks might do. And that's the main thing that we're hoping to do here, is to sort of give you guys the tools to experiment with everything else on your own and become, more conversant in it, more familiar with it, more comfortable with it, more confident in it on your own. Because that is sort of the foundation of Science Olympiad and stuff like that anyway. Some of it's testing what you know, but a lot of it's testing how you can solve a problem based on what you know. And if the stuff that you know is the more, how do I put this? The more the underpinnings, like how it might work and stuff like that, as opposed to just memorizing facts about it, then you can solve problems. You can solve more complex problems. You can solve problems. And that always makes things more interesting too, because if you go like, oh, it works because of this, then you can start doing all sorts of crazy things when you're experimenting with Scratch. So that's the blocks palette with additional mini soapbox by me. Then you've got the stage, which is where all the stuff happens. So anything that any of these blocks that you click together to do will happen over here on the stage. You can see the result on the stage. That's basically your output. Then we've got the sprites and backdrop area. Sprites and backdrop basically allow you to set up new sprites. This cat is a sprite. The backdrop is the white. You can add new sprites. You can change the sprites. You can change the cat sprite. You can change the backdrop from white to something else. Stuff like that. It'll basically allow you to affect this so that you can make your program more complex or different. Maybe you don't always want a cat on a white backdrop. You can do that too with this area. And of course, the scripts blocks over here are a part of the larger script area, including the editing area. This is the editing area, just because this is where you drag and drop all of your blocks to. So if you ever want to drop a block in here, then you can do that. And it's always done in this area in order to create your Scratch program. And that's how this all works, is just dragging and dropping stuff. You don't have to do this stuff, by the way. This is just me sort of walking through what all the different things are. You don't have to drag random blocks over if you don't want to. Although you can just to test it out. Then you've got the Costumes tab. The Costumes tab is where you can edit the sprite further, give it animation if you'd like, to change the colors on it, to do all sorts of stuff. If you want to sort of customize this cat sprite to your liking, you can do that in the Costumes area. If you want to add additional frames for maybe making the cat look like it's walking or something like that, you can do that. If you want to add an additional something that makes the cat look like it's doing like the YMCA or something like that, you can do that. You can do that all here in the Costumes area. It's basically where you can customize your sprites, as opposed to add new sprites over here in the Sprites area. Then you got the Sounds tab. The Sounds tab is where all your sounds happen. And that was the point right there where I remembered that all of my sound is coming out of my headphones, and I just partially deafened myself with a cat meow. But yes, so you can add new sounds here. You can create sounds of your own. You can add effects to these sounds. You can play it in reverse to make it weird and creepy. Okay, well that's not gonna reverse. Here we go. You have to highlight it first and then reverse it, and then suddenly you have a reversed cat meow. And I should really stop playing that because it's very loud. But that's where all your sounds are going to happen. So you can add new sounds there. You can record your own. You can edit the sounds that exist. The one sound, the cat meow, and then you can reference those in your blocks. So we're going to get started on our very first Scratch program. This is going to be a very, very simple, very rudimentary little thing, but I'm going to basically explain every step of the way so that we can understand why we're doing these things. And I apologize in advance. At some point you might be going like, where is this all going as I talk about these things? But my intention is to sort of get you guys a little bit more, give you guys a little bit more understanding of why we're doing what we're doing, so that you can do it on your own and you know why you want to do something like that. So what we're going to do is we're going to get started. We're going to have the cat move. That's all. Well, among other things, but we're going to have the cat move. So you might notice that there is a category that might be perfect for that. It's motion. Motion deals with movement, right? If we want the cat to move, we should probably select the motion tab. So that's what I'm going to do. So I'm going to click the blue motion tab right here. And I've got all these blocks. Move 10 steps, turn 15 degrees, turn 15 degrees, point direction 90, point towards mouse pointer, go to X, Y, go to mouse pointer, glide 1 second to X, Y, change X, so on and so forth. I'm just going to use the first one, though. I'm going to use move 10 steps, and I'm just going to click and drag over here into the editing area, and I'll have you guys do this as well. So if we move 10 steps, what do you think? The cat's going to move up, down, left, right? What direction do you think the cat's going to move in? You can throw that into the question box if you think you had the answer to that. Okay, we got a vote for right. We got another one for nowhere. We got another one to the right. All right, interesting. I like the fact that somebody said nowhere. All right, so to spoil it right now for you guys, yes, the cat is going to move to the right. I understand why you said nowhere, though. I like that because A, it may have been a trick question, and B, it's moved 10 steps in what direction? It's not really specified. Now, this is one of the things, yeah, left to right. It does need a trigger action. It's not going to move anywhere. I just meant the specific step itself. But that's another good point. It won't do anything necessarily until we give it an event to get started with. I just meant the thing itself. So yes, when they refer to steps, they refer to moving in the left to right direction. 10 steps in this case will be 10 positive x. Well, what do I mean by that? Well, if you look down here in the lower right-hand corner, you'll see there's an x and a y, and the numbers are constantly changing as you move your mouse along the canvas. That's because we need to be able to tell where a certain thing is on a screen, right? We need to be able to tell, hey, so I want you to reference this thing right here. And you might go, where? And I go, right here. That doesn't make any sense to you because right now I'm pointing with my finger. And you can't see that. But if I say, hey, it's the thing at 0, 0, then you know that there's a cat there. If I move the cursor to 0, 0, we can see it's right smack sort of in the middle of the cat. And we can use that as a reference system. We can use that to keep track of wherever the cat is. If we say, hey, what's at, x10 and y5, well, let's move over there, x10 and y5. We can move around until we find these things. We can see, oh, it's more of the cat. Well, what about x150 and y200? Nothing, because y doesn't go that high, first of all. X goes to 150, which is about right here. Y goes up here to 180, so nothing's there. We can go down to the negatives too. So we can say y negative 180 and x negative, 200. So what they are, they're just sort of labeled points on the system, or excuse me, on the screen. How did I say system? So you can imagine that there's just a whole grid of points, and I'm doing a really poor job right now of drawing a grid. But there's just a whole grid of points that all have a number. And if we ever want to reference this point of grids, we refer to it by its number. So when we say we want the cat to move 10 steps, it's moving forward 10 to the right, 10 of these points. Then we're going to have it say hello for 2 seconds. So that, I'll just tell you right now, that's in looks. We can have it say hello for 2 seconds. We can snap it to the bottom of move 10 steps. Unsurprisingly, that's going to have a little speed bubble pop up that says hello, and it's going to sit there for 2 seconds. We can change the value by editing this. We can have it say hello for 3 seconds by changing the value in there. Then we've got the final step of the process, which you guys already picked up on or you already knew about, is we need to give it something that makes it happen, a trigger. As it stands right now, if we hit the green flag, nothing's going to happen. Nothing's going on because we've not told, remember, computers are dumb, we have not told the computer when to do this. Just pop that out of there. We have not told the computer when to do this. So it doesn't know when to do it, so it's not going to do it. So what we need to do is move over here to events, and we've got a whole bunch of little, as you can see, they got these rounded tops, which just, which let you know that these are the beginning of these scratch chains, because Scratch always moves from top to bottom. Always, always, always. So it's always going to move 10 steps first, then it's going to say hello for 3 seconds. It's never going to do it the other way around, because Scratch always moves from top to bottom. So by giving this a rounded top, we sort of understand that nothing goes above this. This is a starter. This is what starts the events. So this one labeled when green flag clicked. Hey, look at that. We got a green flag here. So anytime we click the green flag, it is going to start anything that's connected to it. So let's go ahead and snap these two to the bottom of it. So now we should see when green flag is clicked, move 10 steps, and say hello for 3 seconds. Let's test it out. Green flag, boop. As you can see, kind of difficult to tell on my screen. I'm sure you'd be able to see it more easily on yours. But he kind of pops forward a little bit and he says hello. And he's really enthusiastic about it. That's it. Just created your first Scratch program. Really super duper simple. nothing to write home about, but this is basically the hello world of Scratch. And what I mean by that is anytime you're learning a new programming language or anytime you're learning anything with programming, generally the first thing you mess around with is something called a hello world program. And all it does is it says hello world in its own way. And that's how you sort of get yourself comfortable with how to build a small program and work with it and things like that. But yeah, so that's your little hello world moment. You've created your first program in Scratch. Now, based on the fact that some of you already knew about the green flag, this is probably not your first program. You're probably looking for something a little bit meatier to cut your teeth on. And we'll get there. We'll get there. We just want to make sure that everybody who has used it and hasn't used it all is comfortable with it, always on the same page. But for now, got our cat walking forward 10 steps and saying hello to us. Look at that. If I keep clicking the green flag, he keeps walking forward and he keeps saying hello. And I'm actually clicking it a little faster than 3 seconds. So you might see the hello blink, but that's only because whenever the program restarts, it removes the text box and then says it again immediately afterwards. So yeah, so we can see Scratch uses top to bottom sequencing. Now, what we're going to do, well, first what I'm going to do is I'm going to move my cat back to the center of the screen, or as close to the center as I can get. I'm actually going to move him over to the left-hand side. Because we're going to make the cat do this continually without us having to click the flag. We're going to make the cat just walk and repeat hello to us. Because why not? Maybe he's really happy to see us. So that's going to be our introduction to the control part of this part of the Scratch blocks. So under events, you've got control. And I know we've just touched on motion and looks and events. We haven't really done a whole lot with them. These are all just sort of little touches to it. Just there we go. These are all just little touching upon them. So what we're going to do is we're going to touch on the control aspect here. Now, the control aspect is a little interesting compared to the other ones because in motion you've got these sort of flat blocks. Looks, you've got these flat blocks. In events, you've got these blocks with the rounded tops. In control, you've got these sort of alligator blocks. The alligator blocks signify that they wrap around other blocks. Say what? All right, well, let's see here. Now, if I'm to drag this around, I can see that I can, so like with a flat block here, I can insert another move 10 steps in between if I really wanted to. I'm not going to, though. You don't have to do that. But what it does is it just sort of moves the other commands down and sticks it right in that spot. With this alligator that's labeled forever, though, if I drag it over these different ones, you'll notice that the alligator's mouth opens more, which is interesting. Well, let's stick it to the bottom here first. Nothing really seems to happen. But if I stick it in between the when green flag is clicked and the move 10 steps, you know, you got a pretty big alligator mouth. And if I drop it in there, look at that. It's completely wrapped around the move 10 steps and the say hello for 3 seconds. Interesting. Now, as a final part of the control, what I'm going to do is I'm going to take one of these wait 1 second blocks. I'm going to stick it right beneath the say hello for 3 seconds. So we're going to move 10 steps, say hello for 3 seconds, and wait 1 second as soon as we click on the flag, but with a twist. So the hello goes away, and then he does it again. And he's just sort of walking over to the side, and I'm not clicking on the flag at all. And the reason for that is this forever block here. What this alligator block is meant to signify is it's meant to signify something called a loop. A loop is any bit of code that is meant to be sort of repeated over and over. Now, it might be run 2 times, it might be run 10 times, it might be run 300 times, it might be run 1,000,000 times. It might be run forever. It might only be run once, because maybe it won't need to be run once. But anyway, it might run forever. And that's where this block comes in. Notice how it's labeled forever. So the point of this block is it's meant to run anything that is wrapped inside of it forever and ever and ever, over and over again. So Scratch still isn't violating its one central thing. It's still doing the one thing that I said it would do, which is it runs from top to bottom. It's just when it gets to the bottom here, it's got a little command to go back up to the top. That's all it's doing. So it's just running from top to bottom over and 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 over again. And that's nice, because we just made the cat, well, I just made the cat walk from here to here while I was talking, which that was moved 10 steps, what, I don't know, maybe 25 times? 30 times? And if I wanted to do that without using a loop, I'd have to do something crazy, like this. See, I'm just right-clicking on this and selecting the duplicate. Oops. Oops. The duplicate option. And so what I'm doing here is I'm making all of these commands run over and over and over again. So he's going to move 10 steps, say hello for 3 seconds, wait 1 second. Move 10 steps, say hello for 3 seconds, wait 1 second. Move 10 steps, say blah, blah, blah. You get the idea. Trick is, look how long this is. And he's only doing it 7 times here. Because he's only doing it as many times as we told him to. So he's only running 7 times. If we run this, so now he's about here. Now he's about here. As you can see, he'll only do it 4 more times before the program ends on its own. If we wanted to repeat it and have it run about 30 times, we'd have to make this fairly long. Let's actually, so this is 14 times. This is 28 times. Let's stick it right in here. So this is 28 times. And this is still not quite as long as far as how long the program had run as when I just sort of let it run while I was talking to you guys. And it will still end. It will still end eventually. So, get out of here. Get out of here, long block of code. On the other hand, if we just wrap this in a forever loop, it will keep going forever, never, and ever with just 4 commands. Move 10 steps, say hello for 3 seconds, wait 1 second, and do it forever. So maybe you could see the appeal of loops in this case. Loops do a lot of work. They make our jobs as programmers a lot easier, because they take a lot of duplication work, a lot of repeat stuff, and condense it down to just maybe having to type it out once, maybe having to figure it out once. So you yourself don't have to worry about copy pasting code, or worst case scenario, typing it out manually over and over and over and over and over again. Anyway, so that's loops right there. You're more than welcome to give that a try yourself. Just take those commands, put another wait in there, and wrap it in a forever loop. Just one of these alligators here, and just test it out and see it repeat on your own. So yeah, in programming, sequences within a loop restart from the top once they've been completed. Each time they are completed is called an iteration. An infinite loop will continue until the code is stopped. So, and that's an important point. only the stuff that's inside of the loop will repeat itself. So if we take out this wait 1 second, we've got the move 10 steps and say hello, you'll see all of a sudden that he doesn't wait and he just goes flying across the screen. Well, he doesn't go flying across the screen because there's still the hello for 3 seconds. But maybe we reduce that to 0 seconds. And let's see what happens. He just goes flying across the screen. So yes, it's only going to repeat whatever's in the loops. And as you can see, he's not saying hello anymore because it's just flashing on the screen for just a fraction of a second, just the tiniest blip of a second. But if we take it to 1 second, you get the idea. So an infinite loop will continue until the code is stopped. In this case, a forever loop. A forever loop is going to continue to run over and over and over and over again until we tell the code to actually stop running. We have to end the code, which sounds much more ominous than it actually is, but we have to get it to stop because it's not going to stop of its own accord. There's no natural ending point for a forever loop. At what point do you end forever? Never, right? So this is another point. The right click. You saw me sort of doing that in order to create the whole big long string of commands. But yeah, on any of these blocks, you can right click. As you can see, you got a few options: duplicate, delete, add comment, and help. Help will give you a little bit more information about what the command is, so that you can look at that and go, oh, okay, so that's what that's supposed to do. Duplicate, you already saw, will duplicate the command as well as any commands connected to it underneath it. Delete, pretty self-explanatory. I'm going to not delete it though, and well, I'll delete it because you can also check out the undelete function under edit. Just in case you mess something up and get rid of something, you can always check out undelete under the edit in the top menu, in the top part of the menu here. It's an undo and it's your friend. So that's delete. And then we've also got add comments. This one here, this is kind of interesting. It attaches that sort of yellow sticky note to it. And you can go like, hey, so I put this here so the cat seems more friendly to the user. And that's it. It doesn't actually do anything. You notice if I run the program doesn't operate any differently. It is literally just notes for myself, and I can minimize it, move everything over here, so I've got these extra little commands and stuff like that. You might be going like, well, that's incredibly useless. Why would you do that? Why would you add notes for yourself? I can remember everything. Trust me, I say that all the time. I still haven't entirely learned my lesson. I still say it all the time. But comments are, when your programs get larger, very, very, very useful for other people so that they can read your program and understand why you're doing something. So people can go like, why does he have the cat say hello? And they can expand the comment and go, hey, so I put this here so the cat seems more friendly. Oh, okay, so that's why he did it. For other people, but yourself too. Imagine I wrote this and then 2 years later I came back to it. And I go like, why did I do that? Oh, I did that for this. Because you're not going to remember everything you wrote either. And it's not like a story necessarily where you can read the story and go, oh, all right, so that's how the story went. And I see that I had the story go this way because the main character likes to do blah or whatever. There's a lot of sort of writing and rewriting and guessing and sort of problem solving and things like that go into programming that aren't going to necessarily stick in your brain over time. As you come back to things later, even as you're reviewing code that you wrote a while ago on the same program, as the program gets large enough, you might forget why you wrote a different part of the program. As crazy as it sounds, it'll happen. So if you keep your code well commented, you won't ever run into that issue. You won't ever run to a point where you go like, I don't remember why I did this. You can go, oh, I did this because, yeah. You can make notes on every block if you'd like to. Yeah, that's doable. Now here's the thing, is it a wise idea? At the end of the day, that's ultimately your call to make. If every block gets a little bit confusing, then yeah, I could see that being a useful thing. So all of my blocks here have a comment on them. But at some point, you're going to have parts that may still seem to be self-explanatory, but you have a comment on them anyway. And if you have notes in every block, then you might have a hard time finding the one note that you need. So it's striking a balance, you know? It might seem like the solution is to write a note for every block until you get to a point where you've got notes on every block and you go, I gotta sort through all of my notes in order to figure out why I did this one thing. Versus maybe you leave a longer note at the beginning of all of these blocks. So if we delete this note, delete this note, delete this note, delete this note, and then here is, for instance, this loop has the cat walk forward and greet the user over and over. Maybe that's enough of a note for you. So you go, this loop has the cat walk forward and greet the user over and over. Oh, okay, so yeah, move 10 steps. I see that. All right, cool. Say hello for 1 second. Awesome. And wait 1 second. All right, so that's just a wait. But that's what this loop does. So I can, as I'm going through different loops, and these loops are 30 commands long, I might just click on a note and see like, okay, so this loop does this, and this loop does this, and this loop does this. So that kind of a thing too. I'm not saying that that's necessarily the answer either. If you guys start programming a lot, you guys will be able to start trying to find and strike the balance that works for you. I'm just giving you some guidelines that might help. All right, so that's going to do it for today. Since it is 6:52, tomorrow we're going to start getting into costumes. We're maybe going to mess around with sprites a little bit, or excuse me, Thursday, not tomorrow. Sprites and backgrounds, and then we will sort of touch upon all of the different major parts of Scratch at the end of this slideshow. And then we'll mess around with some more stuff in Scratch, another slideshow. But again, the whole idea is not necessarily to give you an exhaustive look at everything that exists in Scratch. It's to understand, hopefully help explain why certain things exist in Scratch and why you might use the different things in Scratch and all the different features and stuff like that so that you can experiment with them yourself and get more comfortable and familiar with them. But like I said, that's going to do it for today. I've got a few poll questions here that I'll ask you guys. I'm going to try and get at least like 80% response on it. So if you guys could vote, it helps us out greatly because there's stuff like, you know, did I go at a good pace? Did you understand the content? Stuff like that, so that we can sort of dial it in and make it as helpful as possible for you guys in the future. And in the future might just be the next lesson or the lesson after that. It's, you know, you can, if you vote, you can help see the results of this pretty soon, so that you guys can get as much information as possible. The science. They will, I do not believe they will, but let me actually download this and I'll throw it into the handouts part.
Hey, can I answer a question on the mechatronics or anything, man? I just step back in.
Oh yeah, no problem.
Great.
Is there a place to get these presentations from?
Yes.
Oh, okay.
We're gonna record them, and then they're gonna be put up on both the North Carolina State Science House, and they will be also uploaded on Young Engineers of Today. You can go there.
Oh,
okay.
What about the PDFs?
Yes, we'll put those up as well.
Okay, excellent.
So we'll get the PDFs for the teachers and the students and for everybody involved.
Perfect.
Okay.
Well, there you go. All right, so let me go ahead and do the first poll question here. It's pretty straightforward. Just click on the answer that seems correct, or hopefully is correct to you, and yeah. All right, we're at 81%, so 5, 4, 3, 2, 1, close. All right, so for the most part, it was fine, but it hovered a little bit over on the too slow side. So that's a little bit on the low end of what I'm comfortable with, but that's good. I like that better than a little bit higher and, a little bit more on the too fast side, because then, content tends to get missed and people tend to get left behind. I realize that maybe makes it a little bit less exciting for those of you that found it to be too slow, but things will start to pick up as we get further along as well. So you might find that the pace is beneficial in a later lesson. So we'll keep it as it is for now. If it continues to be too slow, then maybe we'll see about making it up. All right, the next question. All right, 81%. So 5, 4, 3, 2, 1. Close. All right. So by and large, good job. Glad to hear it. That's definitely good. Let's see here. I'm with the. Oh, well, hey, there you go. Perfect. As we got people of all ages learning. Glad to hear it. All right. So next one. Could you hear me clearly? I'm working on keep in mind here, I'm working on a different headset than usual. So things might be a little bit different on Thursday. We might switch between the two different headsets. So things may change. So keep an eye out for that, I guess, ear. Anyway, 94%. So 5, 4, 3, 2, 1, close. And hey, all right, so I'm glad at least for the most part you could hear me. All right, excellent. So that's going to do it for today. If you have any questions, I'm here. Otherwise, you're more than welcome to head out. Have a wonderful couple of days, and we will see you on Thursday with more Scratch. No problem. Thank you. Apologies, I forgot to mute the mic before drinking some water. No problem, Usha. Do you have to be on the webinar or at the webinar at the exact time? Nah. Okay, so no, not necessarily, because we usually spend a few minutes beforehand doing a little introduction and stuff like that, talking about maybe some important things upcoming and stuff like that. But in the interest of not missing that kind of stuff, I would recommend it, but you're not necessarily going to miss the lesson either. Yeah, for sure. I noticed that there was a student attending the webinar. May we invite students to join?
Yes. Yes.
Okay, excellent.
We'd love to have students doing it.
So there you go. Yeah, definitely.
All right. Well, I think, Tom, are we all set so we get the next class started?
I think so. Yeah, I'll go ahead and close this one out. You all have a wonderful couple of days. We'll see you on Thursday.
Yep. Thank you.